Law of conservation of mass is what? It states that mass can neither be created nor be destroyed. Like if this is the beaker here, it's your I'm taking example of HCl. If 5 HCl is there and 5 Cl is there. So if we will do some chemical reaction in this beaker, so the
Ma'am, won't
product,
there be 5H
hmm,
and 5Cl?
yeah, 5H and 5Cl.
Okay.
Here also 5H and 5Cl. And if we will, after chemical reaction also, there will be 5H and 5Cl. है ना? Means your mass is not adding also, not subtracting also. It's equal, right? So that's law of conservation of mass. Now, like here, A plus B giving reaction C plus D. Let's say this is 1 kg, this is 2 kg. So in the product here, what we will get? We'll get 3 kg because if we are adding 3 kg, then what we are getting 3 kg. It's equal. Your mass is equal. Correct? Second, this is the law of constant proportion. It states what? It states that in a chemical substance, the element are always present in definite proportion by mass. Now, what is the meaning of definite proportion by mass, Shazan? What is the meaning of this definite proportion by mass?
It's present in definite amount.
It's
It's given
like,
its by.
huh. For example,
Ma'am, like
H2O
the
here, huh.
hydrogen, ma'am, H2O
Hmm.
is, ma'am, one of hydrogen and 8 of oxygen. Like in 9
Yes.
grams of water, there'll be, the ratio will be 1:8.
1:8. Yes, very good. So this is the law of constant proportion. Here is what, yeah, very good, Advika. Here in H2O, H atomic mass unit is 1, oxygen is 16. So the ratio will be what? 1:8. For your ice water, river water, any water, the ratio of water will be 1:8 only. Okay? If you are taking river, ocean, anywhere water. So this is the law of constant proportion and law of conservation of
Ma'am, laws?
what?
Ma'am, can you repeat the question?
No, I'm saying this is the important laws of chemical combination. These two,
Okay.
conservation of mass and constant
Ma'am,
proportion.
it's just these two, right, ma'am? There are not any more laws?
No, only these two. For chemical combination, there's only two law, conservation and constant proportion. Now we will see. See, this is one example. Like if 4 gram of sodium carbonate reacts with 10 gram of HCl. Okay, this is my sodium carbonate reacting with HCl. So the results in the formation is what? Your carbon dioxide and sodium chloride. So here your gram is what? 4 kg, 10 kg of carbon dioxide gram is 2.5 and 11. So if we will add these two, what we will get? 14 grams. So it means this is which law, Arham? This is which
Ma'am,
law?
is that this like more law of conservation of mass?
Ma'am,
Yes.
ma'am, law of conservation.
Yeah, law of conservation of mass because mass neither be created nor destroyed. It's equal
Not
in both the
destroyed.
LHS and RHS side.
Ma'am,
Yes.
so when it says law of conservation of mass, ma'am,
Hmm.
mass can either be created or destroyed. Ma'am, like
Hmm.
sodium carbonate here is 4.4 grams, and then hydrogen,
4.4 gram.
hydrochloric acid is 10 grams. So, ma'am, is it possible
Hmm.
that like whatever product you get, it's like in
Hmm.
complete different proportions, but then the sum of both is 14. So then can we just say that both of them are equal? And it's law of
Yes.
constant proportion. I mean, law of conservation of mass.
Hmm. We can say that.
And ma'am, when
Okay,
like a
the
gas
proportion
gets
may be
liberated in
hmm.
a particular,
Hmm.
ma'am, when gas that gets liberated in a chemical reaction, do we still count
Hmm.
it for law of constant proportion?
No. Why we will count that?
Ma'am, like in some gases,
The gas is not
ma'am, but
liberating
then
over
like the
here, na?
mass is changing, right?
Yeah, but gas is not liberating now. Only we need to calculate the mass of the LHS and RHS side. If these two is equal, that's okay.
Okay,
Hmm.
fine.
It's not like
Yes,
here
ma'am.
is 14 or here is 15 or 18 grams. No, mass is equal. That's it. Okay.
Yes, ma'am. Yes, ma'am.
Okay. Next, this is what? This is your Dalton's atomic theory. So here, So what is Dalton's atomic theory? Any point you remember?
Ma'am,
Anybody? Hmm.
ma'am, I remember a few points.
Uh-huh.
Ma'am, like
Tell me.
the first point was that like atom is the smallest part of matter and it is indivisible. It is the smallest unit of matter
Yes.
and it is indivisible. And then second, atoms
Yes.
can neither be created nor destroyed in a chemical reaction. And then I remember one point that was like atoms of same elements are same in like all respect, which is like mass, size, and all. It's the same, and it's like different in different elements. And like, man, that's all I remember. And I remember one more about like whole, man, something about whole proportions.
Hmm. Arham, do you remember
But I
any
don't
point?
remember the point.
Arham, any point of Dalton's atomic theory? What he gave, which theory he gave, what are the points?
He said all atoms have the same mass. I mean, all atoms have different mass and different properties, and they are indivisible.
Okay. Shazan, any
Yes,
point?
ma'am. Ma'am, I saved the point which I was.
Hmm?
Ma'am, no more points, ma'am. Arun ma'am, Advika, I've saved,
You
and I don't remember any
forgot?
other. No, I
O-
didn't forgot, ma'am. I said Arun, I've saved the point which I
Okay, okay,
wanted
okay.
to.
Okay, okay. So first point is what? Ki all matter is made up of very tiny particle, which is called an atom. Second, atom are divisible particle which cannot be created or not be destroyed in a chemical reaction. है ना? Third is what? That atoms of a given element are identical in mass and chemical properties. Now, what is the meaning of this sentence? Identical, and here is that atoms of different elements will have different mass and chemical property. So the atoms of a given element are like this is let's say one box, and here lot of helium atom is present. Okay, so means all the atoms, all the elements are same helium, so it will have what? It will have same mass and same chemical property, correct? But if atoms of different elements, here let's say this is also one box, helium, hydrogen, carbon, nitrogen, all different types of atoms are present. So this will be what? That they'll have, obviously they'll have different masses, different chemical properties with respect to each other. But here, if in this all the helium or only one element is present, then they will have a same mass and same chemical properties. Okay. Next point is atoms combine in the ratio of small whole number to form compounds. What is the meaning of this? Atom combine in the ratio of small whole number to form compounds. It means कि atoms will only combine in a whole number. For example, hydrogen H1O2, like this, if this thing will combine, it will form your hydrogen. So it's not like it's forming 2 by 3 or some point wise or some rational thing. No, no. The whole number is there. 2 is your whole number, 1 whole number, 5 whole number. So I'm not writing fraction. I'm not writing point wise, not even rational. So only the whole number is there which will combine and they will form a compound. Second was the relative
Yes.
number of So
Ma'am, is there
second
any
was ki,
specific order for writing these, or can we write it in any
what
order?
what?
Ma'am, is there any specific order for? Is there any specific order for writing these, or
Order, what do you mean by order?
no, like
Which
points
order?
and can you just randomly arrange them?
No, we don't write points now in this. Like if I'm writing, let's say H2SO4, so can I write H2.1SO4.1? No, right? We will
Oh
write
no,
in a
no, oh,
whole number
no,
only.
right.
So
Okay.
that's the
No,
theory
no,
he
ma'am.
gave.
I meant
Hmm.
like, ma'am, like I
Hmm.
meant like you're saying like for whole numbers. So, ma'am,
Hmm.
it's like not possible that it's in any it's not in any fraction or anything like because it is
Hmm.
possible that only a fraction of the molecule is getting exchanged, right?
Come again?
Ma'am, how can you say that it has to be in whole numbers when it's possible that only a fraction of it is actually involved in the chemical reaction?
There it is involved, but if I'm writing the formula, then I have to write in a whole number only, no? Like any
Okay, fine.
formula, HCl formula, H2SO4, C6H12O6, like this. So it whole number only, na? 12, 6, 6, it's whole number.
Yes, ma'am. Got it.
So this is the theory, and the last one was the relative number of which kind of atoms are constant. Like this, this is constant. This will never change. I can't write H3O2. I can't write HO2. So H2O is constant compound. So these six theories he gave. Now what is this? This is the one more. This was the numerical. And here, these are the symbols of element. Okay, so what is the symbol of magnesium? What is the symbol?
MMG.
Mg?
Ma'am, sorry,
Okay.
MMMM.
Yeah, Mn.
That's
Mg
manganese.
is for Mg is for
Ma'am,
magnesium, no?
magnesium. Ma'am,
Magnesium.
magnesium.
Hmm. Hmm.
Ma'am, I thought you asked magnesium, so.
Okay. And what is the tin? What about tin?
Ma'am,
Ma'am, SB
ST.
something?
Ma'am, ST.
SP.
SBBB.
SN na. SB is for antimony.
Ma'am,
Okay.
but isn't like the scientific name for tin stannum? So won't it be ST?
No, it will be SN.
Ma'am, but like shouldn't the name of a particular uh element like be the first three letters or first two letters?
But that was different. But in some of in some cases, this that rule will not be there, है ना? For example, if I'm
Yes, ma'am.
writing, okay, wait, let me show you more. For example, see silver. It should be SI, but it's
Yes, ma'am.
AG,
Yes,
है ना?
ma'am, got it.
So this you have to remember for
Got
gold,
it.
for tin, silver. Okay.
Yes, ma'am.
What
Yes, ma'am.
about aluminium?
The aluminium is Al.
Al. And what is the atomic number of zinc? Atomic number
Zn.
of zinc. Zn. Don't know,
Mm,
Adam. What is the
yes, ma'am.
atomic
Zn,
number?
ma'am.
Hmm.
What, ma'am?
What is the atomic number of zinc?
Can I
Zinc, is
refer to
it
my notes?
20,
Thank you.
30?
30. It's 30. Good. It's 30. Huh. And okay, so what about calcium?
Ma'am, Ca.
Atomic
20?
number. Okay, for you it's 20. Advika, for you it's how much? For calcium.
Ma'am, I'll be 20.
20? Yes, it's 20. Calcium 20. Okay, one more last. What about nickel?
Yes, ma'am.
Nickel symbol
Nickel.
and atomic number. Hmm.
Ma'am, nickel.
Ni
Ma'am,
28.
ma'am, Ni will be the like
Hmm.
a symbol, and the
28.
atomic number is 28.
Yes, very good. Okay, next. This is the periodic table, no? So
Yes, ma'am.
here, this part, okay, first let me erase this thing. So this part is showing you what? Atomic number? It's visible or not? Means 5 is atomic number.
Yes, ma'am.
Yes, ma'am.
Down its atomic mass. If okay, wait, let me
And
write
then up
for
is mass
helium.
number.
Huh. What? Here is the name of element, which is boron. This is the symbol B. And state electrons per energy level is 2 and 3, and electronegativity value is 2.0. Okay. So this you have to for see if this is what this is the red color means hydrogen. Hydrogen is in red color. All the dark blue is alkali metals. Means these are lithium, sodium, potassium, cesium. Okay, all are alkaline metals. Alkaline earth metal is these your beryllium, magnesium, calcium, strontium. Transitional metals in some like some brownish kind of a color, green. And what about this? What is this? This one, violet color. These are what? Helium, neon, argon, krypton.
Ma'am, they're inert or noble gases.
Yes, noble gases. Okay. So next was your atom. What is atom? You all know atom is the smallest unit of matter which may or may not have an independent existence but always take part in a chemical reaction. Atom will always take part in a chemical reaction. So here, and what is the atomic radii is measured in? In length, in meter, in centimeter, in what?
Ma'am, is it nanometers?
It's nanometer. And nanometer
Atomic
is
mass unit. No,
what?
ma'am, atomic mass unit is for like measuring the mass, and like length and all is for nanometer.
And what is 1 nanometer? Which is 1 to the power minus 7 into and 10, sorry, into 10 to the power minus 9 meter. Now, next is what? This is the symbols of some element are formed from the first letter. We will see from here. Where's the first part? Okay. First, this we will see that symbol of some elements are formed from the first letter, from the name and appearing later in the name. Now, you guys tell me any example. Tell me the example of the sentence. Symbols of some elements are formed from the first letter and a letter appearing later in the name.
Ma'am, aluminium.
Aluminium,
Ma'am, Al.
Al, but it says that letter appearing later. Okay.
Oh, later as
Oh,
in like, ma'am,
hmm.
later as in like
Next,
in the middle. Or
next,
like, oh, ma'am,
next.
ma'am, then there's
Uh,
manganese, magnesium, zinc.
zinc also, yeah. Zn.
This one.
Manganese means
Magnesium,
Mn.
manganese.
Magnesium Mg. Yes, magnesium Mg. Chromium also, right? Chromium is
Yes.
Cr.
Yes.
Copper.
Copper is
Copper is
Cu.
like from the scientific name.
Copper is Cu, Arham. No, this can't be there, no? Next is what? Other symbols have been taken from the name of
Ma'am,
the.
zirconium.
Okay. And this is what? Which is taken from a Greek. So iron or Fe, sodium, which is like different. So see, here,
Gold,
Advika,
silver,
gold is Au,
silver,
silver,
ma'am, gold,
mercury,
silver, ma'am,
potassium,
ma'am, antimony,
hmm, antimony, which is Sb, tin,
ma'am,
which is
mercury is
Sm.
also,
Yes.
ma'am, PB is the symbol for what?
Pb for lead.
Ma'am, lead, ma'am, lead.
Yes, good. So here are the some drawbacks of Dalton's atomic theory. So what is the drawback of Dalton's atomic theory? Just a minute.
Isobars and isotopes, ma'am, like he said that, ma'am, Dalton stated that, ma'am, first of all, he stated that atoms are indivisible, ma'am, they can be divided, and ma'am, he said that atoms of the same element are like alike in all respects, but it's
Yes. So here, so according to Dalton's,
like,
what?
nothing. That's
Okay,
correct.
okay. It's okay. So according to Dalton's atomic, were indivisible. Atoms were indivisible, no? Which cannot be divided. He gave this theory that atoms are indivisible and atoms cannot be destroyed. So the drawback is over here is that atoms are made up of three particles, which is distributed, na? Your electrons, protons, neutrons. So this was the first drawback of Dalton. What about second? He gave this theory also that atoms of an element have exactly same mass. But here, if I'm writing about carbon, see, carbon is having all these three masses. You're 12, even you're 13, even you're 14. So this theory also means this is the correct, but this theory also got failed. Next. Next was atoms of different elements have different masses. But if we will see Ar and calcium, these two will have same mass, 40 and 40. So this theory also failed. Okay? In exam, this thing will come that write drawbacks of Dalton. So you have to write these 3 points. Your isotopes, your iso means the different mass thing, your same mass, and atoms which cannot be divided, but it can be divided into three particles, electron, protons, and neutron. Next. Next is what your, this is what? This is some symbols and your elements. Cobalt, Ne, Zn, uranium. You have to remember the periodic table. Okay? 1 AMU is this much, 1.67 into 10 power minus 27 kg. And what about this? What is isotopes and isobar? Isotopes means same number of
No,
protons.
isotopes means same number
Hmm.
of protons. Isobar means same number of same mass number.
Yes, good. Same number of proton, but different number of neutron. Isobar means same mass number. Next. Next is your about molecules. What is molecules? What is molecule? No idea.
Ma'am, molecules are a group of
Hmm.
atoms that are bonded in some way.
Example?
Numbers 2.
KMNO4.
Yeah, all are molecules, है ना? So it is defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. Like if I'm writing HCl, HCl is what? HCl is a molecule, but this shows an independent existence as water. Correct? And what are
Yes,
you
ma'am.
doing? Okay, next. This is also, what is this? Razi Arham. Okay, this was, so here, your what is atomicity? That number of atoms present. Mono, di, tri, tetra, and poly. Now you tell me, what about H2O2? H2O2 is what? Monatomic, diatomic, poly, tetra. What? Tell me, what is H2O2? Arham, what is H2O2?
What, ma'am?
What is the atomicity of H2O2? Monatomic, di, poly, tetra. What?
Die and
Die. But how, Aram? It's two and two. Total is four.
then it's quad.
Quad. Okay. And Shazan, what is this? H2 and O2. Hmm?
What, ma'am?
What is H2O2? What is the atomicity of H2O2?
Okay, no, I forgot.
What?
I forgot.
Okay, Advika.
Ma'am, as a hydrogen oxide.
Hmm? Okay, let me show you. Aram, 4 means tetra. Okay. Yes. Mono means one, dia two, tri three, tetra four. Poly means more than four. If I'm writing, let's say S8, sulfur 8, it means this is what your, this is what? Poly, right? Because this is atoms more than 4, no? Atoms is present more than 4, so that's why it's poly. So these are the atomicity. You have to go through this, Shazan. You have to go through this notes, okay? Next topic is about this molecules and compounds. Okay, so here if let's say we will take this example, H2 H sorry C2H5 and OH. So here total how many like combining elements are what? So your hydrogen, so carbon, hydrogen and oxygen, that's it. And what is the ratio of this? 12 is to 3 is to 8. Okay. If I'm saying C2 and H2, so what is the combining element here? C2 and H2? C2H2 combining elements? Arham,
Yes, ma'am.
C2H2 combining elements.
CNH.
No, you can't say like that. Carbon and hydrogen.
Carbon and hydrogen.
Carbon and hydrogen. Okay, what about C6H12O6? Shazan, what are the combining elements over here?
Carbon is there,
Hmm.
hydrogen is there, and oxygen.
Okay, carbon, hydrogen, and oxygen. Good. So these are what? These are the molecules of some compounds. Molecules of compounds, basically. So here your all compounds are present. Here are the combining elements, and there are the ratios. Next is what? This is let. What Advika? What project are you making?
I'm not making the project. Oh, ma'am, that's my
Okay,
mom.
okay.
She's on a call.
Okay, okay. It's okay. So here, prediction of number. Your N and H mass ratio of this is what? This is the ratio simply. Like for ammonia, NH3, your ratio is simple 1 is to 3. Okay. So these are the prediction of numbers of atoms from your mass ratios. So mass ratio means mole ratio means mass ratio upon atomic mass. For example, if we'll take any compounds, it will be 14 by 14, your mole ratio will be 1. What about ions? What is cation? Cation is plus or minus?
Ma'am, it's
Cation,
positive.
cation is positive, anion is negative.
Negative.
Negative, positive. Anion is negative, no? Huh.
Ma'am, can I
So
put you
here,
in water and come?
go. So cation is the positively charged ion are known as cation. For example, if I'm writing your like if I'm writing H2O, so it will be H plus and O minus. So this is your cation and this is your anion. Okay. Next, polyatomic ion. Polyatomic ion means if I'm writing like this, CSO4 2 minus. This is what poly. Why? Because here your two atoms are present, like 4 and 2. So this that's why this is poly, and this is also because 4 and 2 is over here. So more than 4, it's poly. What about valency? Valency. What about valency? Like valency for here, if Ca2 plus Zn2 plus, the valency will be 2. Al3 plus Fe3 plus, so valency will be 3. Okay, means combining power. Valency is basically your power. What is next? This is the writing of a chemical formula, that how we write a chemical formula. For example, hydrogen sulfide. So H is 1, sulfur is minus 2. So if we will do cross multiplication, we will get H2S. What about magnesium chloride, which is MgCl2? How we are getting this? This is actually 2, this is 1. If we are cross multiplying this, we will get MgCl2 over here. Okay. Next is your, this is also your simple compound. SnO2 means SN2 and O1. So this and this will combine, it become SnO2 or SN2O4. If in Sn there will be 4 and O there will be 2, so it will be SN2O4. Okay. Next is your molecular mass. This is your mole concept. Arham, you know na about mole concept? Everything you know. Hmm. Shazan, how's your mole concept? You are
Ma'am,
able to
it's
solve. What?
yes, ma'am, it's almost done.
What at home? So this is what molar mass molecules, like in 1 mole of carbon atom, there will be how much? This number. So in 1 mole of carbon atom, you will have Avogadro's number of C atoms and 12 number of C atoms. In 1 mole of molecules, you will have this much number of molecules and the molecular which is there in gram. 1 mole of any particle like atoms, you will have this number of particle and relative molecular mass. So this is the formula. Like for number of moles, the formula is given mass upon molar mass. Number of moles formula is given number of particle, which is your atoms or molecules upon Avogadro number. Now, what is the Avogadro number, Shazan? Avogadro number?
I'm at 6.02 10 to the power
Hmm.
23.
Yes, Avogadro number is this. And these are all the examples we had, which we are like we have already discussed all the examples. So, any doubt in this chapter anywhere? No?
No, ma'am.
Okay, so in the next class, we will continue with the next chapter. The revision of the next chapter we will do.